Check this out. We have a unit square, a semicircle, and a tangent. The question is, what is the exact area of this shaded triangle?
To see what's really going on, we need to break it down and rebuild it precisely.
Let's be precise. A unit square means every side has a length of exactly 1, and the semicircle has a diameter of exactly 1. I love this problem because drawing one line, this tangent from midpoint M, completely breaks the symmetry. Our goal is to find the exact area of triangle MCP. No guessing, no estimating. We want the precise value. Let's move the diagram over to the left to make some room for the math. To solve this, we need to leave the visuals and trust the calculation. Geometry isn't just about coordinates, it's about connections. Let's look at the segment connecting the midpoints. Since the square is 1 unit high, this vertical line MO is also exactly 1. It acts as the backbone of our shape. Now look at triangle MTO. A key rule in geometry is that a radius is always perpendicular to its tangent. That 90-degree angle is our way in. In this right triangle, the hypotenuse MO is exactly 1. It works out perfectly. The radius OT is 0.5. Since we have a right triangle, we can simply apply the Pythagorean theorem to find MT. An MT comes out to be the square root of 3/2. This number actually terrified the ancient Greeks, but don't worry, we can handle it. We now have the height of M, but P is still a mystery. Let's look at where it sits. P isn't floating randomly. It's locked in place by 2 specific tangents. Notice that P is the connecting point for 2 different tangents. In math, intersections like this are huge clues. Euclid proved this a long time ago. If you draw 2 tangents from the same point to a circle, they have to be the exact same length. So let's call this length PB y. Because of that rule, the other length, PT, must be y too. This is the key. See how the hypotenuse MP is just these 2 segments added together. It's MT plus TP. Now look at the yellow triangle, MCP. Since the square is 1 unit wide and M is in the middle, MC is exactly 0.5. And since the whole right side is 1 and the bottom bit is y, the top part must be 1 minus y. And just like that, we have all 3 sides of a right triangle written in terms of y. Now we can solve it. We've turned the geometry into algebra. Now we just have to compute it. Be careful expanding these. It's easy to forget the middle term, that negative 2y. Look at that! The y squared terms cancel out. That makes things much easier. Now, let's clean this up. Numbers on the left, y's on the right. We can get a cleaner answer by multiplying by the conjugate, 2 minus root 3. Now that we have y, finding the area is straightforward. The area is exactly root 3/8. It started with a simple square, but that tangent line introduced the irrational number. But that's what makes it beautiful. Subscribe for more math tricks.